Okay, let's solve multi-step equations and identify some of the most common mistakes. So right here, we see negative 20 equals negative x minus 6x. Whenever you have like terms on the same side of the equation, that is always a good place to start. So I know that negative 4x and 6x are like terms. If you don't remember what like terms are, you can see my video on combining like terms. So if we had negative 4x and negative 6x, this would combine to be a negative 10x on the right. We can keep our negative 20 on the left. And now asking ourselves, if the goal is to get the x by itself, what is currently keeping the x from being by itself? Well, it's currently being multiplied by negative 10. So in order to undo being multiplied by negative 10, we would divide by negative 10. But we can't just do that to one side. We have to do it to both sides. That x being multiplied by negative 10 and divided by negative 10 cancels each other out. So we're just left with the x. And negative 20 divided by negative 10 is a positive 2. So x equals 2, or 2 equals x. So they become a little bit more complicated, and students often get caught up when we have variables on both sides of the equation, right? We can't combine like terms on the single side of the equation. So what I like to say here is you have to commit to a side. You have to choose the side you want the x's on. And usually what I do is find the side that would result in a positive value. So in this case, I'm actually just going to subtract 7x from both sides. I could also subtract 8x from both sides, and that would leave a variable on the right. In this case, after crossing out are 7x and negative 7x. 8x minus 7x is simply 1x, or x. We have a negative 2 on this side, and we're left with a negative 9 on this side. So now we just have a variable on one side. So this becomes a lot simpler to process. We can simply add 2 to both sides and get x equals negative 7. If you're having a difficult time adding and subtracting positive and negative numbers, you can see my video on adding and subtracting positive and negative numbers. Okay, so this one will be interesting, right? We have variables on both sides of the equation, but they're the same. So either way, if we try to choose the one on the left or choose the one on the right, we're going to end up subtracting 4m from both sides. They'll cross out here, and we get negative 4 equals 4m minus 4m is 0. And in algebra, whenever you find yourself in this situation where you have two things that are equal to each other, but it's not true, right? This is not true. Negative 4 does not equal 0. That's just a false statement. So you can go ahead and put your does not equal line through your equal sign and say no solutions. Meaning there's nothing you could put in the universe for m that would make this equation valid or true. So in this case, once again, we have variables on both sides of the equation. This time, I'm going to choose to subtract 5p from both sides. Why am I choosing to subtract 5p from both sides rather than subtracting 8p from both sides? Either one would work. I just like to do it in a way that results in a positive value. So our 5p and negative 5p cancel each other out. That leaves us with negative 14 on the left. Now we have 8p minus 5p, which is 3p plus 4. We want to get this p all by itself, so we should try to get rid of everything else. We can subtract 4 from both sides. Negative 14 minus 4 is negative 18. This positive and negative 4 cancel out. And one last and final step, what's happening to that p currently? Well, it's being multiplied by 3. How do you undo being multiplied by 3? You divide by 3. These p's cancel out, and you get p equals, what is negative 18 divided by 3? Well, that's a negative 6.